Hi everyone, thanks for coming. I'm a lead developer at ThoughtWorks, and I've been on a number of different projects over the years, and I really like the idea of a Dockerized development environment and the idea of a Go script. Has everyone heard of the idea of a Go script? Who hasn't heard of the idea of a Go script? Okay, so the idea, it's a script, it's checked into the root directory of every repository, and it's a way that allows developers to really quickly discover the tasks that are available in that code base. So you might have things like building the code, you might have things like running the unit tests, all that kind of thing, like having it all in one place and having it really easy to discover what you can do in that code base. So I really like these ideas, and I tried these approaches on a number of different projects, but I found the existing tools and the existing sort of ways of working quite lacking. And so I sort of gave up, and I built the tool that I would want to use and how I would want to work. And I call it batect. And despite the questionable choice of name, it is in use by dozens of teams now, and was recently rated trial by the ThoughtWorks Tech Radar in the most recent edition. So that's the second highest rating, which is really cool. And so I'll talk a little bit about why I built batect as I go through the presentation. But I think, for me, it gives you that sort of promised land of a beautiful Dockerized development environment, but also the promised land of a Go script, and brings those things together really nicely. But before we get into that, I want to talk a little bit about what I mean by build and testing environments. And so I'm going to do that with an example. So let's say we're at a bank, and let's say we're on the team that's responsible for the international transfer system. So that, the system that allows customers to transfer money from one country to another, possibly with some kind of foreign currency conversion as well. And let's say we've gone for a microservices style architecture. It looks a little bit like this. Our team is responsible for everything in orange. So we've got our service, and for some reason we've chosen to implement it in Java. And then we've got a database behind it that's using Postgres. And then we consume a service provided by another team called the exchange rate service. So fairly ordinary microservices style architecture. And there are two things that are really important to me and that I want to talk about today. The first is, how do we take the code and produce an executable artifact from it? And then how do we test that thing before it goes into production so that we know that it's probably going to be okay? And this is where the development environment comes in. There are two main parts. The first is the build environment. And so this is where we have the tools and the configuration that we need to build, unit test, and package our application, so it's potentially ready to go into prod. So this is things like compilers, this is things like build tools, this is things like libraries and runtimes, all that kind of stuff. Whatever we need to go from source code to a unit tested artifact ready to go into prod. So in our example from before, this would be going from Java code to a jar file. If you were building a front end, it would be taking your JavaScript and making a bundle out of it. Whatever you need to do to get that thing that's ready to go into prod. The other half of the development environment is testing environments. And this is where you have external dependencies for integration testing. So you might have things like databases, you might have things like queues, caches, other services, whatever it is that exists outside your application that you want to test with and check that you can work well with. And so you might have some fakes in this environment. It might not all be real software, but you might have some real implementations as well. You might have multiple different configurations that you want to have. So if you're doing different kinds of testing, different styles of testing, you might want to have different setups. And we'll talk a little bit about that later. And so in our example, it's pretty simple. We just need the exchange rate service and the database. But in the real world, it can quickly become quite complex and quite difficult to manage. And so having some way to manage this stuff is really important. So let's talk about these in turn and talk a little bit about how batect and this approach makes doing this stuff much, much easier. So let's start with the build environment. And let's start with a little bit of a picture. So we start with our computer or our CI agent. On that agent, we can start up a container. Inside that container, we've got all the bits and pieces we need for our build environment. So it's things like build tools, it's things like libraries, it's things like runtimes, like we said. Within that container, we also mount in our code, so that we've got access to it. And then we run each of our commands inside that container. So rather than running it on our computer directly, we run it inside that container, and that gives us a number of great benefits, and we'll talk a little bit about them in the next slides. So this is Dockerized development environments is not a new idea, and so I want to talk a little bit about this approach and the special sauce that batect brings and the opinions it has and why they're important. So the first really big benefit of this approach, and this is a benefit that applies to Dockerized development environments in general, is that isolation. So within that container, you're not affected by anything on the host machine, and anything on the host machine is not affected by anything inside the container, unless you explicitly make those things talk to each other. And that's really important from the perspective of consistency and repeatability. It solves that works on my machine type problem. It means that you don't have configuration drift. All that kind of stuff is solved for you. And that comes from a number of different sources. That comes from that isolation. It comes from using that same image as the basis for that environment every time, or using the same Docker file for that as the basis for that environment every time. And it also comes from starting with a clean container every time. And this is where batect starts to diverge from the sort of traditional Dockerized development environment approach. Every time you run a command, it spins up a new clean container or set of containers to run that command in. And that gives us a really, really strong consistency guarantee because we know that we're starting from exactly the same point every single time. That also makes CI agents much simpler to manage. Because all of a sudden, all you need is Docker, and you no longer need to manage different tools and different conflicting versions of tools and like the different requirements of different teams and sort out all that stuff. All you need is a fleet of agents that runs Docker, and teams can do whatever they want within those containers without interfering with one another. That's great on its own, but it also means that it increases that team autonomy, it increases that decoupling between teams. Like, you as a team have the ability to go and add stuff to your environment if you need it without having to talk to another team that manages those agents. And it also means that and in addition to that, both locally and on CI, Docker's caching of images and caching of the build state means that this doesn't take a long time. Like, it's still really, really performant. And you get all those other great benefits as well. So another really important part of this approach is that both the shell script that starts batect and the config file that drives it live alongside the application's code, and they're checked in alongside the code as well. And we'll come back to the config in a second, but this shell script is really important. It serves as that entry point into the tooling. It serves as that Go script. It serves as that place where developers can go having no knowledge of the repository. Like, they can just clone it down, run that script, and discover what tasks are available to them. And that means it's really, really easy to onboard new team members or to introduce new people to that code base. So I did a survey of my colleagues at ThoughtWorks last year now, and I asked them, how long does it take you to get up and running with a new code base? And the answers were quite shocking, to be honest. Like, it was anywhere between 2 hours and 2 weeks. So we had developers spending the first 2 weeks of their time on a project or on a team just getting up and running, which is an awfully long time to spend doing this kind of thing and not providing any value. Whereas with this approach, all you need to do is install Git, install Docker, clone the repository, and you're good to go. And that comes from two places. That comes from that discoverability and that Go script idea, but it also comes from that really, really quick setup time of Docker. Because you can pull down existing images, it's really, really fast. And so I did an experiment. So I took a completely empty virtual machine and wanted to go from that empty virtual machine to having the sample application up and running, having run all the different commands, run all the different tests, all that kind of stuff done. It took me 30 minutes and 4 seconds. And the first 20 minutes of that was just installing the operating system itself. The next 4 minutes and 30 seconds were Docker and Git. And then the last 5.5 minutes were running those commands for the first time and pulling down those images, getting Gradle to pull down dependencies, all that kind of stuff. And so this was an experiment, but it also plays out in the real world. So we were using this technique on a project in Germany. We had a new developer join our team first thing on a Monday morning. And he was able to get up and running and make his first meaningful business valuable commit by lunchtime on his first day. And that wasn't just because of classic German efficiency, it was also because of this technique. Another really big benefit of this approach is the ease of change. Because the environment and those task definitions are committed to version control and versioned alongside the application like anything else, means it's really, really easy to change that and share that knowledge with your team members. Rather than having to tell them, this is what you need to do now, you just change the task, they just run batect build like they always have, and they magically get the new stuff. And it's the same for the environments. You can just update that Docker file, or you can switch to a new version of an existing image, and they'll get that automatically. Batect will take care of pulling it down, setting it up, doing whatever needs to be done to make that work. And again, this plays out in the real world. So I was on a team building a JavaScript-based Lambda last year. We were using batect, and we'd been using NPM. And we decided we'd been having a bunch of trouble with NPM. We wanted the performance benefits of Yarn. And so what we did is myself and another developer, we changed the configuration in the batect file to use Yarn instead. We checked that in. We didn't tell anyone. People knew that it was going to happen, but we didn't tell anyone that we'd finished. And half the team didn't even notice that we'd done that because it just happened for them automatically. And that's really cool. Another really important part of this ease of change is that wrapper script. That drives the versioning of batect itself. There's nothing more that you need to install or update or manage. It will automatically pull down the version that you're using based on that wrapper file and update it for you automatically, and it happens very quickly. And of course, the other big benefit of having everything committed to version control like this is that if you ever need to go back in time and go back in history, that environment changes too, the version of batect changes too, the task definitions changes too, like all that stuff that stays in sync. And so you don't have to think about it, you just get it, it's just automatic. So all of that's like really nice, that's all really abstract. So let's talk a little bit about an example and see a concrete example of what the configuration looks like. And yeah, so let's start with the configuration file and start with the definition of that build environment. So it looks a little bit like this. So this is the definition of the container that we run our builds in. I have omitted one or two things from the slides just to make it really clear. The full example is available online. But you can see here we're using an existing OpenJDK image for Java 8. And then we're mounting our code in there, and we're mounting a case directory in there so that we don't have to download our dependencies every time we run the application. Once we have that in place, we can start to build up different tasks that run in that environment. So for example, we might have a build task. And so we can define here, we've got a build task, we can have a little bit of help information about it, and we can define the container it runs in and the command that runs in that container as well. We can then add some other tasks. So like unit testing is a fairly common thing. So we can add some unit testing tasks. Again, we define the container we want to run it in and the command to run in that container. And on top of that, we provide a description and a group for every task. And that's really important when we start thinking about that Go script and that discoverability. So any project that uses batect, you can clone it and run a single command, and it will give you that help information, list out the different tasks, and tell you about them. So it looks a little bit like this. You can run batect list tasks. It'll spit out some output that looks like this. That happens for you automatically. You don't have to write a bash script or anything like that to make this happen. It just works. So that's what it looks like in the background. Let's have a look at what it actually looks like as a developer when you're running this thing. So on the command line, you're in the code directory. You can just run, say, batect unit test. It'll make sure that that container that you need is pulled down. Once that's done, it will then start up that container, start running the tests inside that container, let them run, and then as they finish, it will then stop everything, clean up, and it's as if that never run. Like it's as if it was never there. Like batect goes to great lengths to make sure it cleans up after itself. And we'll talk a little bit about why that's really important when we start talking about how other tools approach this problem. So that's the build environment. Let's talk a little bit about testing environments as well. And to me, this is where the technique and where batect really comes into its own. But before we can get into the testing environments, I want to talk a little bit about terminology. Because like I said at the start, different people have different approaches to testing, and there's lots of different ways you can approach this problem, and I want to talk a little bit about how I approach it and the terminology I use. So you're probably all familiar with the test pyramid, and everyone seems to agree that the bottom layer of the test pyramid is unit testing. Once you get above unit testing, everyone seems to have different names for different things and different ideas of what those things are. So for me, when I talk about the next layer up, I talk about integration testing. And for me, what that is, it's the things you want to unit test, but it doesn't make sense to unit test. So this, the stereotypical example is you've got a class that talks to the database. It's got a bunch of SQL queries in there. If you were to unit test that thing, all you'd be really testing is your ability to copy and paste the SQL query from your production code into your unit test. It's not super valuable. What you really want to do is run that class in isolation against the database and see if it produces the results you expect based on that query. So that's integration testing. The next kind of test that I like to do are journey tests. So this is where you're spinning up the application and testing it from the outside, treating it as a black box. So going back to our example from before where we're providing an API, like spinning up the API and hitting it with HTTP requests and testing that it works together in completeness. It's then hitting other dependencies, so it might be hitting a real database or a fake database or a downstream service, and we'll see an example of this in a second. If you're using a UI, by the way, so some people would call this functional testing, and so teams have used this approach in batect to do headless browser testing where they spin up a browser and simulate clicks with Selenium and those kinds of things. So we can use a similar approach to what we saw for the build environment to orchestrate this process of test environments as well and get all those great benefits that we saw before. So we get that isolation, we get that ease of onboarding, we get that ease of change, and we get that consistency and that repeatability. And this, like, in particular, consistency and repeatability is really, really important when it comes to these kinds of testing. Because like, historically, they're quite flaky, they're quite difficult to manage, they're quite unreliable. And so Google did a study a couple of years ago, and they found that 84% of their new test failures in their code weren't due to logic errors, they weren't due to bugs, they were due to flakiness, they were due to environmental issues. And they found that that led to alarm fatigue. They found that that led to people ignoring those failing tests. And they found that people ended up putting stuff into production that shouldn't have been in production. Like, the tests were telling them stuff that they were ignoring. And so, yeah, if we can make these environments more consistent, we can reduce that flakiness, we can have much more confidence in our tests, and like, we can be much more confident putting stuff into production and knowing that it won't break stuff. And so, yeah, like, going back to this team in Germany, like, we were using this approach, and we were very confident with our tests. Like, we didn't have any tests that we considered flaky, and that was thanks in large part to this technique. In addition to these 4 big benefits, though, like, one of the other big benefits we get for this when we start talking about testing is the ability to run stuff locally. It's generally really, really difficult to spin up test environments like what we just talked about locally. So going back to the survey I did of my colleagues, over 50% of them couldn't run integration or journey testing locally, but really, really wanted to. And that means that, that slows that feedback loop. Like, it shouldn't take minutes or hours to get feedback, it should take seconds. And using an approach like this means that you can get that feedback in seconds. It also means that you can really consistently run these kinds of tests in isolation on CI, and it largely removes the need for big integrated environments. So again, going back to the team in Germany, we didn't have a big integrated environment that we used for any kind of functional testing. We only had 2 environments. Like, there was prod and not prod. And not prod was only used to test the fact that we could deploy things safely before we started pushing it to prod. It wasn't used for functional testing and verifying that the application behaved in the correct way. So yeah, those are the benefits. But now going back to sort of practicalities, if we want to do this, we have a bunch of different containers we need to manage. And coordinating all these different containers gets quite difficult. And so yeah, let's go back to journey testing and go back to our example and use that as a discussion point. So we've got the application itself. We've got that Postgres database, we've got that exchange rate service that's developed by another team, and we've got some kind of external test driver that's hitting it with requests and checking that they're what we expect. So what do we need to do if we want to run our tests like this? First of all, we need to compile the application. We need to build the Java code into a jar file or whatever it might be for you. We then need to pull the images for these different things or build images for these different things. And then we need to make sure we start all this stuff in the right order. So first we need to start the exchange rate service and the Postgres database, our dependencies. Then once those are ready, we can start the application itself. And then once the application itself is ready, we can kick off the tests and run all that stuff through. And this is a really important thing. So how do we know when those things are ready? So batect takes advantage of Docker's health check feature. And so for those of you who haven't come across it, you can define in an image a health check that will run inside that image continuously. And it can then report back to Docker to say, yes, I've actually finished starting up, I'm ready to go, you can hit me with requests. And so batect uses that as well. And so then it knows that it can start things once they're ready. And it also means that you no longer need to have polling in your tests. It means you don't have to keep retrying and do all these kinds of fallback type things. You can know that if you're started, everything that you depend on is ready to go, or is at least reported that it's ready to go. We can also use Docker's networking features to run this in an isolated network as well. That gives us 2 big benefits. The first is we no longer have port conflicts. So within that isolated network, we have our own namespace of ports. So I can have port 80 inside the network, and I can have something running on port 80 on my machine, and those 2 things won't conflict unless I explicitly pull that port out onto my machine. The other big benefit of running everything in an isolated network is that it gives us a really easy way to address the different containers. So by running everything in that network, we can assign a name to each of these containers, and so by default, batect will just use the name of the container that you give it. And so then you can just address the different containers by that name, and that makes it really easy to write really clear tests. So batect makes this really, really easy to set up, and so let's jump into an example. And yeah, so I'm going to focus on journey testing, but there's also an integration testing example on the sample project. I'll put the link up at the end. So again, we'll start with the containers. So we have 2 containers. We've defined one for our database and our exchange rate service. You'll notice this time, instead of using an image, we've defined a build directory. So that's a directory with a Docker file. Within that Docker file, batect will then automatically pick up and build that image when it needs to, and take advantage of Docker's build cache to do this really, really quickly. So it's not going to rebuild it from scratch every single time, and we'll see that in a second, that it's still really, really fast. With those containers defined, we can then start to define some different tasks. So again, we can define a task for Jenny testing. Again, we'll define a command to run and a container to run it in. You'll notice that now we can specify that there's a prerequisite task. So we can sort of codify that idea that we need to compile the application before we run the Jenny tests. And we can also specify that the test runner, in this case the build environment, is reliant on the international transfer service, the application. And batect will understand that map of dependencies and make sure that's up and running before we get started. And so, yeah, so the application is defined a little bit like this. You'll notice that on the previous task, we didn't have to define the fact that we also need a database and an exchange rate service. So that by defining the dependency on the application itself, the application container can then say, I depend on the database and the exchange rate service. And batect will understand that graph of dependencies and start things in the right order and do that as quickly as it can. Defining things in this way also makes it really easy to reuse different containers. So let's say we want to have another task where we just spin up the application for local testing. We can take this container, we can define a task that looks like this. Again, we can say, like, run that container. And again, it will do the right thing in terms of the dependencies. It will start things in the right order. Yeah, so running that looks a little bit like this. So you'll notice I can just run batect Jenny test. It will kick off a build. It will run the compilation step we saw before. Once that finishes, it will then start building and pulling the images for the test environment. And so you see that fly through very quickly just there. As soon as the database and the exchange rate service are built or pulled, it will kick them off. And then it will kick off the application itself as soon as that's ready. And then as soon as that's ready, it will kick off the tests. So batect is quite intelligent about how it parallelizes work. And that means that it's really, really fast and it doesn't slow you down too much. Yeah, so it runs a test after that. Once the tests are finished, it cleans everything up. And again, like it doesn't leave any resources hanging behind. So yeah, that's what testing looks like. And I just want to take a little bit of a detour and talk a little bit about the path to production. So if your target environment is a Docker-based environment, so something like Kubernetes or ECS or whatever it might be, there's a really nice connection here, right? Like you can build your application once locally or on CI or whatever it is. You can test it, you can test that artifact, and then you can take that exact same artifact and just promote it straight to production. And you can use that same thing all the way through, and that's really nice. Having said that, like this technique is not limited to things that target Docker. So I've used this with Lambdas, like I mentioned before. I've used this with front ends, like statically hosted front ends. Like there's still an advantage and still benefit to working in this way. But there is a nice connection there, of course, if you are targeting something like Kubernetes. So I mentioned right at the start that one of the drivers behind me building batect was my frustration with other tools. And so one of the most common questions I get at the end of this talk is, what about Docker Compose? And it's a very valid question because it's a tool that I've used in the past for this. And it's probably the most commonly used tool for this. But I find that it's just not quite right. And the reason for that is it's good at what it's designed for. And it's designed to stand up a stack and stand that stack up for a long period of time. But what we really want to be able to do is provide a really nice dev experience. We want to be able to pull together different containers in different combinations. And we want to be able to do that really quickly. And we want to be able to do that temporarily as well. So I touched on the fact that batect is quite intelligent around the parallelization of work. And so that leads to a really big benefit over Docker Compose in terms of speed. So yeah, I ran an experiment. So I've got the Jenny testing setup that we just saw for batect, and I've got the equivalent thing for Docker Compose. I ran both of them. On a warm build, batect is 5 seconds faster, which works out to be 17% faster. And that includes all the time taken to actually run all the compilation step and the tests themselves and all that kind of stuff. And to me, this is just the beginning. I haven't spent a lot of time trying to optimize the performance of batect yet. This is just purely coming from the parallelization of work. And I think there's a lot of opportunity to make it even faster again. Another really big benefit of batect over Docker Compose is the model. So in batect, tasks are a first-class citizen. And so that gives us two big benefits. The first is that GoScript type functionality, like that discoverability and that sharing of tasks and that codification of tasks and sharing them really easily between team members. And it also enables concepts like prerequisite tasks. So things like, you have to run the build before you run the Jenny tests. Whereas with Docker Compose, you need something outside Docker Compose to drive that orchestrate that process and make that really obvious and make that really easy to use. It's also really, really easy to pull together different combinations of containers for different tasks in different ways. Like Docker Compose does have the concept of like including things, but it's a little bit more cumbersome. Here you can have everything defined in one file. And just in general, like batect is built to support this workflow, and so it means it doesn't feel like you're fighting the tool as well. The final big benefit of batect over Docker Compose is the developer experience. It goes to great lengths to make it really easy to use and make things just work. And this is really, really important when it's something that you're using all day, every day. So some of the things it will do for you automatically is things like dealing with proxies for you. It will handle file permission issues with Docker on Linux for you. So if you've ever used Docker Compose on Linux and you've got something that builds some kind of build artifact, you'll know it gets created as root. Batect can help you solve that problem really nicely as well. It provides that Go script, it provides that discoverability. You saw the user experience before, like it's really clean, it's really nice, it's really easy to work with as a day-to-day tool. As I mentioned before, you don't need to install it. Again, it's all driven by that wrapper script, whereas with Docker Compose, you need to install it, and you need to make sure that everyone upgrades themselves so they get all the new features. And finally, in general, it goes to great lengths to be a good citizen and clean up after itself. Even really extreme cases, like it will do as much as it can to do the right thing. Whereas with Docker Compose, that requires some kind of external orchestration to make sure it's all cleaned up properly. So, hopefully I've convinced you that batect is a great idea and you want to go home and do this right now, or you want to go back to work and do this. So I want to leave you with a couple of suggestions on how you can go home and get started with this. And so my advice would be to start small and work incrementally. And so usually this means start with the build environment, that place where you can build and unit test your application. And then from there you can start to work up to your integration testing style tests. And usually I would recommend starting one dependency at a time. So you focus on the areas that will give you the biggest bang for buck. So things like the most flaky dependency, or the thing that's most difficult to install or most difficult to manage. Whatever that is, focus on that one first and then keep building up your environment. And then once you have all those things set up, it's a really nice progression to Jenny testing because you've got all those components set up and ready to go. You can then use that as the basis for exploratory testing and all kinds of other things as well. If you're interested in this, the docs and batect itself are up online. There's a couple of different sample projects up there for different languages and different environments. Thank you so much for listening.